What I'm going to present is to show how large language models can confirm or reject linguistic hypotheses in order to increase the productivity of linguistic work, and to analyze the potential of large language models for the creation of semantic language resources, in particular for the enrichment of FrameNet semantic frames with new lexical units and annotated examples, and for the semantic classification of lexical units. Actually, we present two experiments with LLMs focusing on linguistic classification and annotation of examples using zero-shot prompting. In the first experiment, new proposals for lexical units evoking a particular FrameNet semantic frame are classified simultaneously with the annotation of examples with the core frame elements. In the second experiment, verb lexical units are categorized into different semantic classes, whereby it is assumed that in certain semantic frames can only be evoked by verbs that belong to certain combination of semantic classes. In terms of linguistic studies, LLMs are already used to recognize and classify specific language constructions, to analyze data within a theoretical framework, to annotate text with relevant linguistic information, to support corpus-based linguistic studies, and so on, of course, with different level of accuracy. Our general workflow is as follows. First, we select the suitable LLMs, mainly according to two criteria, novelty and accessibility. Then formulation of linguistic task, formulation of a prompt template aimed at fulfilling the linguistic task, execution of the experiment and collection of data from the selected LLMs, and human evaluation of the results obtained. LLMs that were used in the experiments to illustrate the capabilities of large language models to assist the creation of semantic language resources are, in alphabetical order, Claude 3.5 Sonnet, Gemini 1.5 Pro, GPT-4 Omni, GPT-4 Omni Mini. And the models were last accessed at the end of July 2024. Know that Claude 3.5 Sonnet belongs to Anthropic's family of multimodal resources, and it is accessible through Claude chatbot and also through the available Anthropic API. Gemini 1.5 Pro is part of Google DeepMind's Gemini 1.5 family and is also accessible through the Gemini chatbot and the Gemini API. And the GPT-4 Omni is the next generation GPT models. The GPT-4 Omni is available via the ChatGPT Plus and the OpenAI API. And GPT-4 Omni Mini is the small version of the GPT-4 Omni model, and is also available through both moduses. We can mention that the model actually replaced the GPT 3.5 in the ChatGPT. Actually, the comparison of the large language models is not attempted by this work by several reasons. And some of these reasons are the following. The models are evolving very rapidly, and new models and updates of existing models are constantly appearing. Some of the models have been improved in a clearly defined direction. And for some of the selected models, detailed information of the architecture, training data, model size, and so on is not available. Our first experiment is called Augmenting FrameNet Semantic Frames with Lexical Units and Annotations. And the experiment aims to have large language models select new lexical units that evoke a particular frame, suggest relevant examples, and annotate them with the core frame elements. FrameNet is a collection of semantic frames, and there is an example of one of the frames. This is the arriving frame. In the FrameNet, frames have definitions. They are constructed by frame elements, which are also supplied by definitions, and some other elements which are characterized them. For example, the definition of the arriving frame element is as follows. An object team moves in a direction of a goal. The goal may be expressed or it may be understood from context, but it's always implied by the verb itself. And there are two core frame elements. Actually, those are the team and the goal. Verbs that evoke the arriving frame in FrameNet are appear, approach, arrive, come, crest, descent, enter, find, get, hit, make it, make, reach, return, and visit. And there is example of the relations, frame-to-frame relations in FrameNet in one step from the arriving frame with red arrows. The a relation of inheritance is marked with the black arrows. The relations precedes is marked, and also with the green dotted arrow. This is a relation sub-event, and the green the blue dotted arrow. This is the relation of uses. This is just to show that the FrameNet is a really very rich semantic resource in which different levels of semantic information actually are encoded. First, we select lexical units which were actually checked by the experiment whether they would be classified as belonging to the frame arriving or not. The method which we use is very simple method which combines the exact matching of lexical units from FrameNet and literals from WordNet and the evaluation of the similarity of the definitions. The approach takes into the account the fact that the WordNet contains many literals with the same form but different meanings. After the mapping, a human judgment is made to decide whether a particular mapping between a lexical unit and literal is correct. Among the lexical units that evoke a particular semantic frame, there are synonyms, hypernyms, hyponyms, which are called troponyms in FrameNet, in WordNet, although the existing semantic relations between lexical units are not explicitly labeled. And the troponym synsets up to a hypernym synset whose literals are mapped with a lexical unit from FrameNet are considered potential candidates. There is an example. For example, lexical unit arrive from FrameNet is mapped to the synset arrive, get, and come with the definition reach a destination. This synset has actually several hyponyms or troponyms with the other term, but only two are shown in this example. For example, those are floating and land set down. And land set down also have several hyponyms, but only one is shown here. This is for land. Only some of the available synsets, which are hyponyms of the selected synset arrive, get, come, are actually selected because only those which answer to the definition of the arriving frame work among the list. As a result, the number of potential new lexical units evoking the semantic frame arriving is totaling in 137. This is an example of the prompt which is used. The semantic frame with a particular name has the definition. The core frame elements are, and they have the definition. Indicate which of the following verbs with the definition evoke the semantic frame, the name of the frame, and those that do not. Give 3 examples of each verb and annotate the core frame elements in the examples. Use this pattern for the output. There are some results of the experiments. Considering the examples given by GLMs are most probably synthetic. Regardless of this, all examples are grammatically correct and sound natural. They are structured to consist of parts interpreted as team and goal, but usually do not contain more than one clause and do not illustrate complex syntactic structures. Considering the selection of lexical units, in some cases, the selected lexical units are used in examples that do not illustrate the intended meaning, which evokes the semantic frame arriving. For example, such negative example is the sentence, the company scaled back production to match declining demand. Some unintended verb meanings in the examples are correctly categorized as not evoking the frame arriving. For example, the new policy aims to get at the root causes of inequality. And in some cases, models provide explanations, for example, to get at implies reaching an abstract or physical destination, making it relevant to the arriving frame as it involves a team moving towards a defined goal. Results considering the annotation of core frame elements is correct in most cases, as long the examples represent the given lexical unit and not others with a different meaning. And not others with a different meaning. For example, the hikers surmounted the peak and gazed out at the breathtaking view. Team is hikers and goal is peak. Actually, this is evaluation of the results of the outputs of the form models. However, I consider this evaluation very irrelevant and not useful because, first of all, because of the reason I've already mentioned. And second of all, because for this evaluation, it was not used preliminary develop evaluation benchmark. However, 20% of the output was manually annotated. And this manual annotation considers both the relevance of the examples to interpret the intended meaning and the correct classification of lexical units when we calculate the score for the lexical units. For example, only if a sentence represents correctly the meaning which was intended and the verb was classified correctly, this sentence was marked in the annotation as true positive, and so on. But this is very time consuming, and I don't really see the point to annotate manually the output of the large language models just to show this table of comparison, especially for the reasons I already mentioned. The conclusions for the first experiment may be summarized as follows. The partial manual annotation of the LLM output shows that the proposed approach cannot completely replace the manual development of semantic resources or manual annotation, but the resulting verb list, the examples and annotations have to be manually evaluated and in some cases rejected or re-annotated. However, the experiment also shows that the LLMs can be used as a second annotator when enriching the FrameNet with new lexical units. And furthermore, it is possible to successfully use LLMs for the automatic enrichment of FrameNet annotations, for example, selected by experts. And the second experiment is called classification of FrameNet lexical units into semantic classes. This experiment aims to have LLMs categorize verbs to evoke a particular FrameNet semantic frame into relevant semantic classes, in this case, aspectual classes related to situation types, also called eventuality types, states, activities, accomplishments, and achievements. And this is a test whether the audience actually has listened carefully to the talks of my colleagues, how we can define activities. So you can answer me. I'm joking, of course. The selected verbs are lexical units that evoke the frame arriving, as well as verbs that were added by mapping with WordNet, 20 verbs in total. Due to their similarity in meaning, these verbs can be conditionally divided into two groups, the group of arrive verbs and the group of approach verbs. The verb, actually we use several linguistic tests which were defined long time ago by many linguists, and most of them are summarized by David Doughty. But also there are some different tests reported by different linguists and different works. We have chosen only 3 of these tests, which discriminate from my point of view successfully activities, accomplishments, and achievements. And those are the tests. The verb occurs with expressions such as for an hour, which means that it occurs in any point in the hour. If the result is positive, activities are clearly distinguished from achievements and accomplishments. Second test, the verb can occur with the verb finish. If the result is positive, accomplishments are clearly distinguished from activities and achievements. And the third test is the verb can occur with the verb stop. If the result is negative, achievements are clearly distinguished from accomplishments and achievements. And this is the template of the prompt. There is a list of verb and the definition. Give examples with each of the verb from the list in the following constructions if the examples are grammatically correct. Verb, team, the verb in the present continuous tense, go for an hour. Team, finish, ink verb form, go. Team, stop, ink verb form, and go. What is the results about the classification? Some models, actually 2 of the models, Claude 3.5 and Sonnet and Gemini 1.5 prompt, correctly distinguish between 2 classes: activities, accomplishments, the group of approach verbs, and achievements, the group of arrive verbs. The other models give examples for all constructions, even if they are not always grammatically correct. All models provide some examples that are correct, but illustrate either a different meaning or a different construction. The output also contains some explanation. For example, Claude 3.5 Sonnet actually produce such note. Verbs that describe punctual actions such as arrive, drive in, enter, get, come, or don't imply a gradual process, some as come on, go up, don't fit well with these constructions in their given meanings. From Gemini 1.5 Pro, approach indicates movement towards a goal, but doesn't necessarily mean reaching it. Arrive indicates the completion of a journey, reaching the intended destinations. According to the classification, we can also say that a clear distinction between activities and accomplishments cannot be made in this experiment. The group of approach verbs is provided with some examples with 4 expressions that are typically combined with activities. For example, the ship approached the island for an hour. This implies a slow, gradual approach. The car near the city for an hour. Similar to approach implies a gradual movement. Actually, these comments are provided by the models. The linguistic text with the verbs finish and stop aim to distinguish achievements verb that do not normally come with after verbs finish and stop because they do not describe the kind of process. In the experiment, examples are regularly given with both finish and stop with the approach verbs. For example, the hikers finished drawing close to the summit. The boat stopped coming near the shore. To summarize, the result of the experiment showed that the verbs in the approach group can be divided either as activities or accomplishments, depending on the context in which they are used, while the verbs in the arrive group can be defined as achievements. And conclusions from the second experiment are that the results may lead an expert to make the correct distinction based on the examples and interpretations provided by the LLMs. The fact that one and the same semantic frame can be evoked by both activity accomplishment verbs, such as approach verbs, and achievement verbs, such as arrive verb, could raise the question of the reorganization of some frames, because the general meaning of the frame arriving is that of achievement. And the general conclusions are as follows. LLMs cope quite successfully with the linguistic annotation of words or phrases expressing a given frame net core frame element. So it can be expected that the automatic annotation of the core frame elements for previously selected examples can be successfully performed by the LLMs. Some difficulties in using LLMs for linguistic classification into spectral classes may arise from the nature of linguistic tests that only work for a particular linguistic context, while there may even be a shift between spectral classes within a word meaning for different constructions and contexts. The use of more than one large language model with the same prompt or prompts allows the confirmation or the rejection of an initial hypothesis. On the other hand, carefully analyzing the errors of the LMs can also help to make one or more decisions. And actually, at the end, I'd like also to acknowledge our project, Ontology of Activity Predicates, Linguistic Modeling, with a focus on Bulgarian, which was funded by the Bulgarian National Science Fund, and which gave us the opportunity to work on such an interesting topic in so different ways. Thank you very much.